To start, let's go over what happens when we actually define a variable. Now, when we write a line of code which initializes a variable, and that code is executed, the computer essentially creates a little space in memory that stores your variable name and its contents so that it can be referenced later. Going back to our cardboard box example from the previous segment, think of this as if you had your own storage facility, and you make a new cardboard box labeled name, and inside of it you put a piece of paper with the word null pointer exception on it. Now, anytime you want to know the contents of your name box, you could simply look inside and see that it has the contents null pointer exception. This is what the computer does, except the storage facility is the memory in your computer, the box is a variable, and the contents of the box are whatever the variable is set to be equal to. Anytime you want to know the contents of the name variable, you can simply call it, and the computer will pull the information that is stored in that variable and use it how the user sees fits. Another thing to note really quickly is that you can actually make a variable without putting information inside of it. This would simply be like if you built up a new cardboard box, gave it a label with a Sharpie, but just didn't put information inside of it. You're simply saving that space in your storage facility for later. This could be maybe because you want to store information in it later down the road, or if you're going to use it to store information given to you by the user, in which case you can't give it information since you don't know what the user will input. Just a note that if you try to reference or point to a variable which does not have any information in it, you'll get what's known as a null pointer exception, which despite being an amazing name for a YouTube channel, is something you generally want to avoid when programming. Now, programming languages allow us to do some pretty cool things with these boxes that we've created. For example, let's say we created a second variable called channel name, and instead of setting it equal to null pointer exception, we instead set it equal to our already created name variable. This doesn't create a space in memory for this new variable, however it simply points to the same location of memory we have already created for the name variable. Going back to our storage facility example, this would be like instead of creating a whole new box labeled channel name and storing a sheet of paper with the word null pointer exception on it, we instead simply added another label below the name box entitled channel name. Now we have two variables which point to the same contents, that being the string null pointer exception. We usually do this to save space in our code for things that we know are going to have the same value. Variables can also be updated throughout your code. For example, let's say you had an age variable, and inside of it was the integer 17. Then, you celebrated a birthday and wanted to update your age. All you would have to do is reference the variable and set it equal to whatever new integer you want the variable to hold. In this case, 18. This would be the same as having a box labeled age with a sheet of paper reading 17 inside of it, and then taking that piece of paper out, erasing 17, replacing it with 18, and then placing it back in the box. Doing this, we are able to easily update the contents of our variables throughout the code as things dynamically shift. As another example, if you were making an RPG, your character would likely have stats such as attack, defense, mana, etc. As the game progressed, you could continuously update the variables so that the player could get more powerful the further along that they went through the game, and you wouldn't have to create new variables. You would simply need to just keep grabbing that box from your storage facility, erasing and replacing the numbers on the piece of paper, and then continue along with your code. Just keep in mind that these variables are nothing more than places in memory in which a certain value is stored, so we can easily update the numbers and their place will remain constant. After the code has run its course, the place in memory is deleted until you run the code again and the program dedicates space for the variable again. Each time you run the code, you're making new boxes in your storage facility, and at the end of the code, you destroy them all to make room for the new boxes next time. Another cool thing you can do with integer, float, and double variables is add them, subtract them, divide them, multiply them, and even modulus them. For example, if you were making a calculator app and you stored the first number the user entered as number 1 and the second as number 2, you could then multiply num1 and num2 together and either print them or store them in a new variable entitled result. Then, each time you run the program, the user could input new numbers into the num1 and num2 variables, and they would simply be set to those new integers that the user inputted and return the result that corresponds to those specific numbers. This allows you to keep easy track of which numbers are which and what's going on in your program, which is extremely useful. Also, while you cannot subtract, multiply, divide, or take the modulus of strings, you are able to add them, like we said previously. Let's say you had a string str1 with the contents hello, and a string str2 with the contents there. You could add str1 and str2 to create a string that had the contents hello there, either storing it in a third variable or printing it out to the console.